Hello, ladies and gentlemen. Welcome back to Physics 20 Kinematics, Lesson 5, the Kinematics Equations, Part 2. A biker passes past the light post at the top of the hill traveling at 4.5 meters a second. She accelerates down the hill at a constant rate of 0.4 meters per second squared for 12 seconds. How far down the hill did she move? Well, first things first, check it. There's no stupid typos in it. Then we go, the initial, final, acceleration, displacement, and time. So her V initials, 4.5 meters per second. And should draw a picture. There she is, going down the hill. Alex, constant rate, 0.4 meters per second squared. 12 seconds. How far down the hill did she move? So we're looking for displacement. Notice we do not have V final. Don't have it, don't need it. Because we can use the formula displacement is V initial t plus 1/2 at squared. So displacement we do not know. 4.5 meters per second times 12 seconds plus 1/2, 0.4 meters per second squared times time is 12 seconds. Now, as you've probably figured out by now, the hardest part of this course is figuring out which equation to use when. Once you get the correct equation, and hint, make a list of everything you know, draw a picture, find the equation that works, then plug in the numbers. So, 4.5 times 12. You'll also notice I tend to chunk this. Sorry, 54 meters. 0.5 times 0.4 times 12 squared. Um, 0.4. Honestly, there's only one significant digit, but I'm going to lie and round it off to two significant digits. 83 meters down. Or plus 83 meters. Okay. I chunk it because it's too easy putting so many numbers in the calculator to make one dumb boo-boo. Okay, so she moved 83 meters in those 12 seconds. Now, a sheep starts from rest, and accelerates at a constant rate of 3.15 meters per second squared for 28.65 seconds. Yes, I got to learn to read more, better. Words, yuck. Anyway, what is the displacement during this time? Okay, the initial, final, acceleration, displacement, and time. So, starts from rest, 0, constant acceleration, 3.15 meters per second squared, 28.65 seconds. And no sheep can accelerate like that. What's the displacement? Now notice we don't have V final. Here's the sheep running. So it's displacement, V initial t plus 1/2 at squared. So let's see. Actually, I'm going to pause it here. You guys plug in the numbers. Tell me the answer. We'll come back and compare results, okay? So do it. Pause the recording. Do it yourself. Okay, guys. V initial is 0, so V initial times time is 0. I got displacement of 1.3 times 10 to the 3 meters, or significant digits, 1.3 kilometers. Now, that's a little bit ridiculous for a sheep, but none of you guys know about sheep. Tasty, tasty sheep. Anyway, plugging the numbers in, that's how you'd solve it. So, the last thing is final velocity if displacement, initial velocity, and acceleration are known, the no time equation. So if acceleration and velocity are known, but time is not, we can still solve for displacement because we have displacement and acceleration. And note, I'm rewriting acceleration in terms of time. Plugging that in here, multiplying it out, we get this equation. Velocity final squared equals velocity initial squared plus 2AD. No time. And yeah, this is the no time equation. Velocity final squared equals velocity initial squared plus 2AD. Now, a cannon is shot with initial velocity 15 meters a second. The cannonball travels for 50 meters with a constant acceleration 2.5 meters per second squared. What's the final velocity of the ball? Or the cannonball, I should say. Well, I don't know. Let's figure it out. V initial, V final, acceleration, displacement, and time. 15 meters a second. Displacement is 50 meters. Acceleration 2.5 squared, and we don't have time. So I can cross out time, we don't need it. And there's the picture. Now, velocity final squared equals velocity initial squared plus 2AD. Velocity final, we don't know. Velocity initial is 15, so this is 15 meters per second squared plus 2 times 2.5 meters per second squared times 50 meters. Now, (225 meters squared per second squared). That's 250 meters squared per second squared. And I'm going to check my math. Sorry, I did that math in my head. 15 squared is 225. Good. 2 times 2.5 times 50 is 250. Good. So add those together will be 475 plus, and then square root of the answer is 21. 21.79. Now, two significant digits, that's 22 meters per second. All right. So far, so good? Yeah, I don't think it's too bad. Now, a helpful hint. At this point in the course, students often have trouble knowing which equation to use. The answer is usually very simple. List all the data you've given, then use whatever of the kinematics equations that fit the data. There's usually only one clear equation that could give you an answer. So use your formula sheet. Now, another helpful hint. If you look at your formula sheet, so far we've only used these equations up here. Don't go using equations you haven't learned about yet. And while we're at it, note here, God bless Microsquish, it is refusing to put in the divide signs here. Just to screw with me. I don't know why. Anyway, make certain they're written on your formula sheet. Those are all the formulas we've learned how to use. And that's what I expect you to be able to know and use to solve this section. If you've got any questions, shoot me an email. Otherwise, good luck. Go do the classwork. I'll see you in class tomorrow.